Welcome to the Deep Dive, the show that takes a stack of sources, articles, research, and our own notes and extracts the most important nuggets of knowledge or insight, giving you a shortcut to being truly well-informed.
We do the reading so you don't have to.
Exactly. And today, we're plunging into a question that could literally reshape our world. Is the future of construction finally moving from the dusty, often chaotic job site to the precise, controlled factory floor?
It's a big question.
It is. We're diving deep into an idea that's actually been around for ages, but, well, for various reasons, it seems to be gaining some serious, undeniable traction right now. Prefabrication and modular construction.
Yeah, you hear those terms thrown around a lot more these days.
You really do. Our mission today is to uncover whether building more like a manufacturing process is genuinely the answer to construction's biggest challenges. You know, things like cost, speed, quality, sustainability.
All the big ones.
Or if, maybe, in that pursuit of pure efficiency, we risk losing something essential, something about how we actually create our built environment.
That sort of craft element, maybe.
Perhaps. So we'll unpack the fascinating history of this concept, clearly define what we even mean by prefab and modular, because they're not quite the same thing.
Good point. Important distinction.
We'll explore the undeniable benefits that are driving its adoption, confront the significant hurdles that have historically slowed its progress, and peer into the future of this potentially transformative approach.
Sounds like a packed agenda.
It is, whether you're just curious about innovative housing solutions, maybe prepping for a high-stakes meeting on supply chain optimization, or you simply love an aha moment that connects seemingly disparate ideas, this deep dive is for you.
We're aiming to connect the dots.
Exactly. Connecting the dots between a really old idea and its profound potential to reshape the very fabric of our communities. Okay, so let's unpack this fascinating history. When we talk about modular or, prefabrication, it's easy to think these are cutting-edge, really modern concepts, products of our industrial age, right?
Right, you think assembly lines, robotics.
Yeah. But the idea of standardized, repeatable units in building, that fundamental sense of a reusable blueprint, it stretches back surprisingly far. It didn't just appear with the steam engine, did it?
No, not at all. What's truly fascinating here is how deeply rooted the core principles of modularity actually are in human construction. I mean, even way back in antiquity.
Antiquity, really?
Oh, yeah. Think of Vitruvius, the famous Roman architect and engineer. He wrote his 10 books on architecture way back around the 1st century BCE.
Okay.
And he wasn't just giving vague advice. He laid out incredibly precise, almost you could say, factory-like rules for designing columns, especially within the Doric order.
Like specific measurements.
Absolutely. He specified their thickness relative to their spacing, what he called intercolumniation, and even prescribed subtle adjustments. For instance, he noticed that columns at the corners of a temple, silhouetted against the open sky, they tend to look more slender than those ones inside. So his solution, make the corner ones thicker by a tiny fraction of 50th of their own diameter.
Wow. That's incredibly specific.
It is. And it's not just about looks. It's a systematic, standardized adjustment to counteract an optical illusion. It's like an ancient form of quality control through a predefined, repeatable rule, almost like a very early CAD program telling you exactly what to do.
So it wasn't just grand theories or aesthetics. It sounds like there was a very practical, almost scientific application of this kind of modular thinking even back then, solving real-world problems.
Exactly. The practical application of repeatable units is evident throughout history. If you fast forward to medieval times, you see architectural masterpieces like the huge church at Cluny in France.
Okay.
Well, historians have found that its immense proportions were based on a very specific modular unit. 5 Roman feet, which is about 1.5 meters.
That wasn't just chance then.
Highly unlikely. It suggests a conscious, systematic application of repeatable measurements for what was an incredibly complex construction project. These were projects on an unprecedented scale.
And they had plans, right? Drawings.
They did, and some are remarkable. We have these detailed architectural drawings from that era, documents like the Reims palimpsest or the meticulous plans for Strasbourg Cathedral. These weren't just sketches. They were sophisticated planning tools, absolutely vital for managing these huge, intricate projects, especially given the truly daunting challenges medieval builders were up against.
Daunting challenges feels like an understatement. I mean, building a cathedral without modern cranes or computers, what kind of obstacles made that meticulous planning, that almost modular thinking, so essential back then?
Well, the challenges on those medieval building sites, particularly for the big cathedrals, were just immense, multifaceted. Imagine trying to organize hundreds of workmen, skilled masons, carpenters, blacksmiths, laborers, all with different skills.
And probably different agendas.
Probably.
Mm.
Then there was the constant, massive struggle to get expensive, high-quality materials, often from quarries far away. Think about transporting heavy stone over, terrible roads and rivers.
Nightmare logistics.
Absolutely. And maybe, most critically, they dealt with serious labor disputes. If workers weren't happy, or if resources ran low at one site,
They just leave.
literally pack up their tools and move to another town, another project where things look better. So the systematic planning, the use of these detailed drawings, the implicit modular units we talked about, even with limited tools, it was a direct, intelligent, necessary response to all that on-site complexity.
Trying to control the uncontrollable.
As much as humanly possible, yeah. Minimizing waste, maximizing labor. And here's a powerful insight. This period also saw the emergence of what one source calls the encyclopedic spirit.
Meaning?
It wasn't just about collecting facts. It was a rigorous, almost scientific quest for comprehensive understanding, applying exact sciences to architectural problems. It marked a big shift away from purely intuitive, craft-based methods and monastic influence towards a more rational, systematic approach.
So laying the groundwork for industrialization.
Exactly. The intellectual groundwork, the conceptual blueprint, centuries before the actual machines arrived. It's one of those aha moments, realizing how deep the roots of structured building really go.
Okay, so that conceptual groundwork for standardized building was laid centuries ago, often just out of necessity. But the idea of truly manufacturing a home, bringing that efficiency to everyday living, that really kicked off more recently in the last few centuries, moving from cathedrals to something more personal.
Indeed. And if we connect this to the bigger picture, the push for efficiency and standardization in construction has been this constant evolving quest. You see it accelerate in the early 20th century with influential figures like the architect Le Corbusier.
Right, famous name.
He was directly applying Frederick Winslow Taylor's principles of scientific management.
Yeah.
Taylorism, optimizing tasks, standardizing processes, eliminating waste directly to house construction.
And
For him, it wasn't just about designing beautiful individual buildings. He was actively thinking about a system for building, a way to produce housing efficiently, almost like a machine produces goods. He saw the house as a potential mass-produced item.
So his famous line, a house as a machine for living, that wasn't just a poetic metaphor for him. It was a literal design philosophy, aiming for factory-like efficiency in homes.
Precisely. And this period saw manufactured components becoming standard in homes much more rapidly. Things we totally take for granted today, like built-in closets or even shower baths, those were considered advanced American domestic design innovations back then.
Because they could be mass-produced.
Partly, yes. Components that can be made consistently and integrated easily. This led directly to concepts like catalog architecture. Pre-designed homes you could literally order from a catalog.
Like Sears homes.
Exactly like Sears, Roebuck & Co. They sold tens of thousands of entire kit homes. Everything from plumbing fixtures to pre-cut lumber shipped directly to consumers all across America. It offered affordability and speed during a time of rapid growth.
And then the ultimate expression of that, I suppose, is the mobile home. For many people, that's the picture of manufactured housing factory-built, arrives on wheels.
That's right. And that represents a really crucial historical inflection point. Our sources define manufactured housing quite clearly as dwellings assembled largely in a factory, with a relatively minor proportion of assembly work remaining to be done on the building site.
So almost entirely factory-built.
Pretty much. It's a perfect example of a fully volumetric unit produced almost entirely off-site. And it gained huge traction, especially in the U.S., in the post-war era, a way to rapidly meet the enormous housing demand.
Right, the post-war boom.
Exactly. It really transformed the idea of what a home could be, moving beyond just components to entire living units and fundamentally industrializing home construction on a mass scale. It provided housing for millions.
We've traced this idea of building off-site way back, but now, today, the terms prefab and modular, they get used interchangeably all the time, don't they?
They really do, and it can cause confusion.
Yeah, because there's actually a nuanced, important difference between them. How do we decode this jargon for our deep dive?
Okay, yeah, that's an important question for anyone trying to get their head around this. So, prefabrication, right? That's kind of the big umbrella term.
The broader category.
Exactly. It refers to any component of a building that's manufactured off-site, usually in a factory, and then brought to the construction site to be put together.
So pre-made pieces.
Right. Instead of making them from raw materials right there on site, it allows for, much greater precision and consistency.
Okay, so not the whole building, but specialized pre-finished parts. Give us some examples, some concrete examples of those components. What falls under prefabrication?
Well, we're talking about a huge and growing range of things, from the very common, engineered wood products, plywood, for instance. That itself is a multi-layered factory-produced component, much more reliable than raw timber.
Right, less warping and stuff.
Exactly. Then there's pre-cut lumber that arrives on site, already sized, maybe notched, ready to go. Manufactured stone veneers, basically artificial stone.
Lighter than real stone, I imagine.
Much lighter, yeah, and more consistent.
Yeah.
But it gets way more advanced. Think of entire pre-assembled wall panels. They could arrive with windows, insulation, even the exterior finish already on them. Just lift them into place.
Wow.
Or utility racks for big commercial buildings.
Yeah.
All the complex mechanical, electrical, plumbing systems pre-assembled on a frame in the factory.
Takes a lot of tricky work off the site.
It does.
Yeah.
Even large structural steel assemblies for something like a bridge. A company like Ruki might fabricate complex components, which are reviewed, maybe edited digitally to fit factory constraints, then shipped ready to be bolted together. It just massively streamlines the on-site work.
That makes perfect sense. Okay, so prefab is components, and then modular construction takes that concept a significant step further, right? Beyond just parts or panels. It feels like the ultimate expression of building off-site.
Yes, exactly. Modular construction involves creating entire three-dimensional volumetric units.
Volumetric meaning like whole chunks.
Whole chunks, yeah. Sometimes fully finished rooms, entire sections of a building, even whole apartment units, all built in a factory.
Fully finished, like painted and everything.
Often, yeah. Bathrooms with fixtures, kitchens with cabinets. These modules are then transported to the site, which, as we'll discuss, is a challenge in itself.
Right.
And then they're craned into position and connected together, kind of like giant Lego bricks forming the complete structure.
That's a great analogy.
The manufactured housing, or mobile home we talked about earlier, is a classic example of this, a dwelling almost entirely factory-built. But today, this applies to multi-story apartment buildings, hotels.
Hotels?
Oh, yeah. Entire hotel rooms built off-site. Hospitals, too, patient rooms, operating theaters sometimes. It's a much higher degree of off-site completion than just prefabrication. Requires even more upfront planning. But the payoff in speed and quality can be huge.
So the core idea, then, is bringing the efficiency and precision of the factory floor to building. Not just making parts, but entire sections or systems. How fundamentally does that manufacturing mindset translate? I mean, making cars is one thing, but making unique houses or complex buildings, it's different, isn't it?
It is different, but the mindset shift is key. It fundamentally changes the whole approach. It moves construction away from what was often a craft-based, sequential, sometimes almost improvisational process.
Making it up as you go along sometimes.
Well, maybe not quite, but certainly adapting on the fly. The manufacturing mindset brings in systems thinking.
Okay, what does that mean in this context?
It means rigorously looking at the entire structure of the building process. The supply chains, the labor flows, the design stages, the assembly sequences, understanding how all the different elements, teams, and materials interact.
Seeing the whole picture.
Exactly. And then deliberately designing that entire system to reduce the bad stuff, waste, errors, rework, and encourage the good stuff like collaboration, continuous flow, predictable outcomes. It's about designing and redesigning the construction process itself, not just the final building. It's a much more holistic, engineered approach.
That emphasis on process optimization, cutting waste, ensuring flow, sounds very familiar. Does this draw from things like lean principles, the stuff that came out of manufacturing like Toyota?
Absolutely. The parallels are incredibly strong. And the construction industry is actively adapting lean methodologies to fit its own unique challenges.
How does that work in practice?
Well, a core practice in lean construction is something called commitment planning. It's not just making a schedule. It's a rigorous process where tasks are screened. Is it clearly defined? Is it in the right sequence? Is it actually feasible? Is the scope right? And then critically, these tasks are negotiated between the person who needs the work done and the person who's going to do it. It fosters reliable, promising, shared accountability. And it's designed to proactively avoid those classic inefficiencies, like bottlenecks.
Bottlenecks. You mean like a production line grinding to a halt because one stage is backed up, even if other people are just standing around waiting?
Precisely. That's a perfect illustration. wasted capacity, downstream delays. There's a compelling anecdote from one source about a plant experiencing delays a lot in heat treat.
Yeah.
Workers were just idle because there was nothing for the guys down there to do while heat treat is cooking the parts.
Yeah.
That's capital and labor just sitting there bleeding money.
Yeah, you see that on construction sites too, waiting for materials, waiting for another trade to finish.
Exactly. Lean principles aim to eliminate that. One strategy is underloading, intentionally scheduling less than full capacity.
Seems counterintuitive.
A little, but it creates various buffers, capacity buffers, inventory buffers, time buffers, even monetary or spatial buffers. These buffers absorb the inevitable variability and allow the system to catch up quickly when things go wrong, preventing the whole thing from seizing up. It builds resilience.
And this systematic approach, this Lean thinking, it actually delivers results in complex settings. It sounds good, but does it work?
Oh, absolutely. There's a great example from a Dow Corning plant that implemented these tools. They drastically improved their on-time delivery, went from only 50% to much, much higher. They significantly reduced inventory and could meet fluctuating demand much more effectively. It shows the real, tangible benefits of applying that manufacturing-like rigor. Huge improvements in metrics that hit the bottom line.
So, if that level of systems thinking can optimize a complex chemical plant, it begs the question, what's the ultimate application? Could you apply this not just to one building, but to a whole city? That seems like a massive leap.
You've hit on a crucial point, and it's kind of the natural endpoint of this thinking. That's exactly where we get into the visionary smart city concept.
Right, the buzzword.
It is a buzzword, but the idea behind it, it's often described as an engineer's or computer scientist's dream come true. Envisioning the city itself as an urban-scale circuit board.
Wow.
The whole system designed for hyper-efficiency. Information flowing instantly from sensors, networks, allowing the urban machine to be controlled, monitored, optimized dynamically, often in real time. And this digital integration, powered by tools like Building Information Modeling, or BIM,
Okay.
that's crucial for coordinating and deploying prefabricated elements effectively on a citywide scale. It enables real-time adjustments, performance monitoring across the whole urban fabric. It's the manufacturing mindset scaled up to a metropolis, aiming for maximum efficiency in everything.
The promise of this approach, building like a factory, really is huge. It seems to tackle so many persistent problems in traditional construction. Let's start with quality. That's often a big concern on job sites, right? Conditions are unpredictable, workmanship varies.
Improved quality control is definitely one of the primary, most compelling benefits.
Yeah.
Absolutely. By moving a big chunk of the work into a controlled factory environment, manufacturers can mitigate that huge variability you find on site.
Like what kind of variability?
Well, think about the natural defects in traditional lumber knots, warping, weird grain, or porosity issues in masonry walls that need tons of on-site detailing and sealing to stop water getting in.
Right, endless potential for problems.
Exactly. In a factory, you have consistent temperatures, controlled humidity, standardized processes. You get much more uniform material properties, super precise cutting with advanced machines like CNC routers, accurate assembly by skilled technicians. It leads to a measurably higher, more consistent quality product. Fewer defects, better performing buildings.
So fewer nasty surprises, better consistency, a much more predictable outcome. For an owner, that must be incredibly appealing, just knowing you'll get a certain standard.
It is.
But does that predictability ever clash with, say, unique customization? Or does the digital design process actually help manage that?
That's a really thoughtful question. And the digital tools actually do help manage that tension. Building Information Modeling, BIM, plays an absolutely critical role here. It enables detailed planning and digital integration before anything physical is built.
How so?
Okay, take the Crusoe Bridge example again. The digital model wasn't just a static picture. It was a dynamic tool shared with the steel fabricator, Ruruki. They reviewed and actually edited components within that model to suit their specific manufacturing constraints in the factory.
So the design could be tweaked for manufacturability.
Precisely, ensuring what was designed could be efficiently and accurately produced. Then that updated, optimized model went back to the designers and contractor for approval. This back-and-forth digital process ensures consistency and accuracy before any steel is cut.
And catches problems early.
Exactly. It facilitates clash detection, finding potential conflicts between structure, pipes, wires, etc. in the digital model before they happen on site, preventing costly rework. It also improves the submittals process, verifying materials comply, so you get both predictable quality and the flexibility to incorporate specific designs effectively.
And that kind of coordination and factory precision, that must lead directly to significantly faster construction. Time is money, right? Delays are killer in construction.
Oh, absolutely. Faster construction schedules are a huge draw, a major pain point that modular addresses. Traditional design bid-build methods are just inherently sequential and often very slow.
Yeah.
Design finishes, then bids, then construction starts.
Yeah.
It can take forever.
Yeah, frustratingly slow sometimes.
BIM significantly cuts production cycle times. Less time needed for shop drawings, automated material takeoffs for ordering. Plus, it handles late design changes much more efficiently. Imagine a client changes a detail late in the game. Traditionally, that might mean redrawing dozens of paper plans. Painstaking. With BIM, you change it once in the model, and all the associated drawings update automatically. Saves huge amounts of time, prevents errors.
That's a game changer.
It really is. It means projects can overcome many weather delays that plague sites and ease the impact of labor shortages. It leads to significantly faster project delivery, quicker ROI. Some modular projects report finishing up to 50% faster.
50%. Wow. Okay, what about worker safety? Construction is still a really hazardous job. Moving dangerous work off-site must make a big difference there.
It definitely does. And this is a profound, often overlooked benefit. So many of the most hazardous activities working at heights on scaffolding, heavy lifting, operating power tools, and uncontrolled, cluttered environments. They can be moved into a much safer, controlled factory setting.
Makes sense.
In the factory, safety protocols can be rigorously enforced. Specialized lifting gear and assembly lines can be used properly. Workers aren't exposed to extreme weather, uneven ground, or the chaos of a busy site with multiple trades bumping into each other.
Less risk all around.
Much less. And while it's not universal yet, some conceptual BIM applications even include automated control of construction equipment, like cranes, and advanced safety planning. The promise is a future where on-site risks are dramatically reduced, protecting workers from injury or worse.
And ultimately, it feels like the clients, the project owners, they benefit directly from all these efficiencies: quality, speed, safety. It just sounds like a stronger value proposition overall.
They do, in very concrete ways.
Yeah.
Think about how often clients already choose manufactured options over custom stuff for everyday building parts.
Yeah.
Like masonite doors instead of custom wood doors, vinyl shutters instead of custom wood ones, steel doors with metal thresholds instead of solid wood. These choices are overwhelmingly driven by the economies of scale and labor that make manufactured components much cheaper and more efficient to buy, install, and often maintain.
So it makes projects more affordable.
Exactly. It addresses that fundamental challenge. Jane Jacobs identified the impracticality of city improvement often boils down to a lack of money for new buildings. Manufactured components help make projects financially viable, stretching budgets further. It's about getting more for less, often without sacrificing quality.
I'm thinking about the bigger picture here too: sustainability, environmental impact. Construction's a huge contributor to waste and emissions. How does prefab fit into that urgent picture? Is it part of the solution?
That's an absolutely critical question for the future, and yeah, it's an area where modular construction really shines. It aligns strongly with the principles of the circular economy designed for recovery, reuse, and recycling. Well, green building standards globally are recognizing this. Australia's Green Star system, for example, credits design for disassembly and dematerialization, using less material and designing things so they can be easily taken apart and recovered later.
And melodies.
LATE is incorporating design with flexibility to encourage buildings that can adapt over time instead of just being demolished. By building components in a controlled factory, it's inherently easier to ensure they can be carefully deconstructed, repurposed, or recycled at the end of their first life.
Less landfill waste.
Drastically less.
Yeah.
It ensures materials stay in the economic loop. Plus, factory production allows for more precise material ordering, cutting waste before construction even starts. And often the precision leads to more energy-efficient buildings too, through better sealed, better insulated envelopes. It's a huge potential leap for sustainability in a historically wasteful industry.
Okay, here's where it gets really interesting though. With all those benefits you just laid out, the quality, the speed, safety, cost, sustainability, it sounds almost too good to be true. Which makes you wonder, why isn't everything built this way already? What's the catch? What are the big challenges, the obstacle course keeping traditional construction dominant?
There certainly are formidable challenges, yeah. And they're complex. One of the primary hurdles, especially for true modular with those big volumetric units, is transportation logistics.
Right, moving those giant Lego bricks you mentioned.
Exactly. Moving these huge, often fully finished sections from a factory which might be hundreds of miles away to, say, a dense urban construction site. It presents considerable complexities.
Like what?
You're dealing with strict road restrictions on size and weight, complex permits across different towns, counties, even states. You need specialized equipment, heavy-duty trucks, multi-axle transporters, massive cranes.
Sounds expensive.
It can be. And planning the optimal route might involve temporary road closures, lifting utility lines, maybe even police escorts, just ensuring safe passage without damaging the module or anything around it. It can be a complex engineering feat. Imagine trying to get a 14-foot wide bathroom pod down a narrow city street during rush hour. Just getting the modules there intact and on time is a major concern, adding significant cost and risk.
Okay, logistics is a big one, and financing is always a tough nut to crack in construction. How does it play out for modular? It seems like it operates so differently from the usual phased payments.
Financing can be particularly tricky, yeah. It's a significant barrier. Traditional construction loans often disperse funds based on verified progress on the site. Lenders like that, they can go out, kick the tires, see the tangible progress on the land.
Physical proof.
Right. But with modular, a huge chunk of the project's value, the modules themselves, is created and stored off-site in a factory. That shifts the financial risk profile significantly.
Lenders might get nervous.
They might. They could be wary of newer, less established modular firms or just unfamiliar project delivery systems. They might struggle to value that off-site collateral or figure out payment milestones for factory work. Plus, you need a lot of upfront investment in the factory before anything happens on site. That ties up capital much earlier than traditional builds. It requires different financial structures and lenders who are comfortable with that different risk profile.
So it's not just building differently, but financing differently, planning differently. It sounds like the entire design process needs a radical shift too. That flexibility designers often have might be reduced.
Yes, absolutely. That's a significant challenge.
Yeah.
The need for a highly upfront, pretty much locked-in design decisions.
No changing your mind halfway through.
Well, not easily or cheaply. In traditional construction, design can be more iterative. Changes, while maybe costly, can often be accommodated relatively late, sometimes even during construction. It's more fluid. With modular, all design decisions, including the really intricate coordination between all the systems, electrical, plumbing, HVAC, structure, finishes, it all has to be finalized much, much earlier, often months before the factory starts production.
Because it impacts the assembly line.
Exactly. Any late changes become incredibly complex and astronomically costly. They mess up the factory lines, the supply chains for components, the whole sequence. It requires this intense level of early commitment, precision, and collaboration among everyone, architects, engineers, the fabricator, a level the industry is still really adapting to.
And then there's that other debate, the almost philosophical one you touched on earlier, craft versus factory. That aesthetic, almost spiritual challenge. Does industrialization somehow diminish the soul of architecture?
This raises that important, deeply resonant question. Does it? Le Corbusier himself, even as a huge advocate for the machine for living, had a nuanced view. He distinguished between a practical house, useful, like a telephone service in architecture, with a capital A, the stuff that moves the heart through shapes and relationships.
So even he saw a difference.
He did. He even worried that rapid tech shifts could leave humans breathless and panting before the tool that he cannot take hold of, suggesting a potential loss of human connection or agency.
And other architects felt similarly.
Oh, yes. Frank Lloyd Wright sharply criticized what he saw as uniform and uncreative architecture, resulting from too much focus on classical styles and, by extension, mass production. He pushed for organic designs, resisting commercial trends, resisting that perceived industrial sterility. Louis Sullivan called the 1893 World's Fair an imposition of the spurious, worried about superficiality, imitation forms lacking true artistic expression, lacking that human imprint.
It sounds like a deep-seated fear, almost, of losing the unique human touch, the artistry, the connection to the maker, all in the name of efficiency. Is there a way to reconcile those?
Exactly. And that perspective is powerfully articulated in Matthew Crawford's book, Shop Class as Soulcraft. It highlights the limits of purely intellectual or automated tech, arguing for the value of hands-on knowledge, the satisfaction of making things. Well, he gives the example of an experienced mechanic. They can often diagnose a car problem better by physically looking at the spark plugs, observing real-world evidence, applying that tacit gut-feeling knowledge, than by just relying on computerized diagnostics, which can be liable to nonsense if they're isolated from context.
Right. The computer doesn't have common sense.
Precisely. It underscores the enduring value of human judgment, skilled intuition, the craft involved in real problem solving. And that's something industrialized construction has to navigate. It's not just about what can be built efficiently in a factory, but what should be. What role does human skill, intuition, artistry still play? The challenge, and maybe the future, is finding ways to integrate the best of both factory efficiency for the core, maybe combined with opportunities for artisanal finishing or site-specific customization. That tension is fundamental.
Okay, despite those significant hurdles, moving giant boxes, financing headaches, the whole soul of architecture debate, this move towards factory-like construction, integrating manufacturing principles, it isn't just theoretical, is it? It's actually happening. It's accelerating. Where are we seeing these principles really being applied today out in the real world?
Well, we're seeing it in the increasing and really diverse use of prefabricated components across pretty much all types of construction, not just houses. Let's revisit that Crucell bridge example from Finland.
Okay.
The digital model wasn't just a static design. It was this dynamic tool shared directly with the steel fabricator, Ruguki. They reviewed and edited components right in the model to suit their factory constraints, optimizing it for efficient manufacturing.
So real collaboration between design and production.
Exactly. Then that updated model went back for final approval. That integrated digital workflow, detailed design plus precise off-site manufacturing is a live example of achieving incredible precision and efficiency in huge, complex infrastructure. Cuts time, cuts waste.
So it's definitely not just simple houses, it's complex structures like bridges benefiting from this factory approach. That really expands the scope.
Absolutely. And beyond big infrastructure, you have manufactured housing, the whole factory-built dwellings. But it goes way beyond that, too. Think about highly specialized components like prefabricated bathroom pods.
Entire bathrooms built off-site.
Yep, complete with fixtures, finishes, plumbing, built in a factory, then just dropped into place in hotels, hospitals, apartment buildings, drastically cuts on-site labor and quality issues in those tricky small spaces.
Smart.
Or entire MEP racks, that's mechanical, electrical, plumbing,
Yeah.
complex pipework, wiring, all assembled in a controlled factory environment, then installed as a single unit. Much greater accuracy, faster installation.
And even basic materials.
Even basic materials. Plywood is essentially engineered wood, factory-made. Concrete blocks are prefabricated masonry units. These are all examples of how construction is already deeply incorporating factory-made elements at different scales. Often without us even thinking about it, it's fundamentally changing how things get put together.
Are there broader applications of the process itself, like lean thinking applied to project management, even for traditional builds?
Yes, definitely. The principles of lean construction, that intense focus on process improvement, managing workflow, desired outcomes, they're being applied to incredibly complex projects. Hospitals are a great example.
Because they're so intricate.
Exactly. They demand rigorous timelines, sterile environments, precise resource allocation. It's a perfect place for process optimization. So while projects like Akron Children's Hospital or St. Anthony Hospital might not have been fully modular, they're cited as examples of building outcomes that significantly benefited from rigorous process improvement. That's a core tenet of factory-like efficiency applied to optimize workflow and coordination, even if the final assembly is mainly on-site. It's about creating a predictable, efficient, higher quality outcome, like a well-run factory.
This relentless drive for efficiency, precision, integration. It leads us towards what many are calling the third digital revolution. A radical rethinking of how things are made, pushing manufacturing even further into the digital realm, and maybe even changing where it happens, bringing it closer.
This is where digital fabrication really takes center stage, yeah. And it's a profound shift. We're seeing the emergence of things like fab labs.
Fab labs, okay. Heard of those.
They're not just places for industrial production. They're also these vibrant hubs for learning, experimenting, community building. Each lab often forms a nucleus for a local fabrication community, hosting classes, workshops, embodying this idea that anyone can be a maker.
Democratizing manufacturing tools.
Exactly. Merging education, experimentation, hands-on creation, giving people access to advanced tools like 3D printers, laser cutters, CNC machines. Imagine your local library or community center having these tools, letting people design and make custom parts for their homes or businesses. It's distributed, almost artisanal, but powered by digital precision.
So it's almost like a return to local craft, but supercharged with digital tools, blurring the lines between maker and manufacturer, individual and industry.
Yeah.
That's kind of an inversion of the old factory model.
Exactly. And the really profound idea here is that decentralized fabrication might have no less profound implications for urban form. It suggests production could realign with daily life as manufacturing literally exits the traditional factory.
So making stuff comes back into our neighborhoods.
Potentially. It could lead society back to a kind of pre-industrial model, but one that's local, user-centric, and digitally empowered. Imagine new kinds of homes for the 21st century that maybe recall old medieval cottages or traditional shophouses, combining dwellings with fabrication, bringing the act of making back into our living spaces and communities, hyper-local, customizable production.
And all of this integrated components, Fab Labs, hyperlocal, making it all, contributes to that bigger vision of smart cities, doesn't it? The ultimate ecosystem application of this manufacturing mindset.
Precisely. Active networked architecture, driven by digital tools and sensors, allows buildings to perform dynamically, almost like living organisms, reacting intelligently to their environment, their occupants, external events, optimizing energy, air quality, everything.
The city as an optimized machine.
That's the ideal, yeah. The engineer's or computer scientist's dream, aiming for urban scale efficiency and seamless control. What's really crucial here, though, is the idea of co-evolving social and technical systems. Recognizing that as technology and markets shift towards these new paradigms, industrialized construction, digital fabrication, so too must our organizations, our institutions, even our social habits. We need to adapt alongside the tech. But this understanding gives us agency, choices in how we shape this future. We can actively design systems that aren't just efficient, but also genuinely beneficial for human experience, community life, urban well-being. It's a dynamic interplay between technology and humanity.
We've certainly covered a lot of ground today, from ancient modular proportions and medieval planning.
Right, 3 mail-order homes.
Le Corbusier's machines for living, all the way to digital fabrication and the smart city vision. The quest for manufacturing efficiencies in construction, for making building more predictable, faster, more controllable. It's undeniably a long-standing one. It's been evolving for millennia.
It really has. Yeah. And if we connect it all back, the clear, compelling benefits, the improved quality, the drastic speed increases, the enhanced safety, potential cost reductions, those crucial sustainability gains, they are powerful, undeniable drivers pushing this shift towards industrialized construction.
Right.
But yeah, hurdles are equally significant, complex. The daunting logistics of transportation, the tricky financing challenges for these different models, and that critical need for super detailed upfront design decisions.
Yeah, and that underlying tension.
And perhaps most profoundly, that enduring tension between the efficiency and standardization of the factory floor and our innate human desire for unique, crafted, soulful spaces. That remains a central, fascinating theme.
So after exploring all this, the long history, the latest tech, the question that lingers, I think, for many of us is this time, finally, the time the prefab and modular revolution is here to stay? Not just as a niche, but as a dominant force. Is it the inevitable future, or will the pendulum swing back?
Well, the future, of course, can't be predicted with absolute certainty. But it can be envisioned. And as we saw with things like Fab Labs, it can even be brought lovingly into being through conscious design choices. Systems really can't be perfectly controlled, but they can be intelligently designed and redesigned for resilience, for adaptability.
Learning as we go.
Exactly. We can't surge forward into a world with no surprises, but we can expect surprises, learn from them, maybe even profit from them. So the question for you, the listener, as you look at the buildings around you, the spaces you live and work in, is this: how will you engage with this rapidly evolving landscape? Will the precise digital language of optimized factory-built construction eventually just prevail entirely, creating a world of, urban circuit boards and maybe standardized living? Or will that innate human desire for uniqueness, for craft, for the artistry and story that comes from human hands, will that always find a way to shape our built environment, even in this super technological age? What stands out to you about how we'll build the world of tomorrow? And what role will humanity's touch ultimately play in it?